So, hi everyone, I'm Vagelis. This is joint work with Kostas from the University of Pittsburgh and Christos from CMU. And what we do here is we use graphs to determine a ranking between teams in a league. We use NFL and NBA data. And what we do is basically we form a graph of win-lose relationships between teams in a league. And we calculate the page rank. And using that, this is a ranking between all the teams. And we use that to determine whether Team A will beat Team B in this week. And it turns out it works pretty well. It works better than having the winning percentage, and it works on par with commercial baselines. If you're interested in more details, find me in the poster. We also have some future extensions on not aggregating all the games, all the weeks in a single graph, but using a tensor, which is sort of a time-evolving graph, to better enhance our predictions. And with that, come to the poster later.
All right, good morning. It's tough for me to talk for 2 minutes here. So our work uses a recurrent neural network to model whether a three-point shot was a make or a miss. And so the problem here was to be able to predict whether a basket was successful. And we made it models from a distance of 2 feet all the way from 13 feet away from the basket. And we used recurrent neural networks, which are a modified form of kind of feed-forward neural networks that are designed to learn sequential information. Kind of simply put, these networks have a memory. These models have had great success in other fields, such as language translation, voice recognition. So what we did in our paper was we applied these to 20,000 basketball trajectories. And we found that using the RNNs, they were able to predict much better whether a three-point shot was successful than traditional feature-rich models. So let me kind of break this down. So the RNN only used the X, Y, Z, and game clock data. That's it, just where the position of the ball was. In comparison, we compared it to kind of two feature engineering methods where the basket had both the distance, the angle to the basket, the distance to the basket, kind of those features as well. And so the RNN here had the ability to kind of learn the trajectories, this kind of sequential nonlinear information. And we recognize that this is a toy example, This is trajectories. The next thing we want to do is take this and apply this to player movement data. I have the poster, and then as well as all the code and data are available online, so you can run the model this afternoon if you want yourself.
Hi, my name is Silvia, and I'm presenting a spatial temporal analysis of tennis matches. So as Sarah said, now we're shifting from an analysis of events to the analysis of spatial temporal data. And in tennis, for example, Hawkeye is a very accurate system that can obtain the position of the ball and the ball and the player in tennis matches. But these systems are generally only available to elite players and elite teams, and we're interested in investigating how this can be applied to amateur players. So in previous work, we've developed a spatial temporal data collection system that is much more affordable and also easy to install. And here I want to present the preliminary work in analyzing this data. So I have some data visualization with heat maps. And also I'm able to extract some statistics about the players, for example, area covered by each of them, which make it easier to compare performance between them. So this is preliminary the preliminary work, so I will be very happy that you come over and give me your feedback.
So it's again soccer in our work. So basically what we're trying to look at how you can evaluate passes happening in a football game. So if you want to know who is contributing to creating scoring chances, you can look at the number of assists a player is making, but that is not really the complete picture that you can have. So what we are proposing is a new metric that you can use to evaluate passes, which focuses on what is the value of having the ball possession in different parts of the field, as you can see on the left side. So in case of Barcelona, if they have outside of the box, the ball, it doesn't really count in terms of being able to score. And then using this metric, how the value of the ball possession changes as a fact or as a result of a pass, Then you can look at and evaluate the passing performance of different players. And then you can see what were the most beneficial passes of different players, and that not only highlights where a player was able to make a difference in the field, but also capture what is their role and what is their capabilities in terms of passing style. So you can have someone who is more focused on the box and the other one that is making sure that the ball arrives to the box. Thank you.
Okay, hi, my name is Amin Verma, and I want to tell you about our predictive system for cricket that we built. So those of you who don't know much about cricket, it's a game a lot like baseball. There's a pitcher and a batter, and the batter is trying to score a large amount of runs. So we were working with a broadcaster who wanted to make predictions in real time. So as the game is going on, we could update the probability of which team is going to win the game and how many runs each batter is going to score. Because cricket is a lot like baseball, and it's nice because we can break it apart into discrete pitches. And so our first pass was actually a simple approach. We built a set of logistic regression models where we could calculate the probability of a player going out and how many runs they were going to score on each pitch. And then we could just do Monte Carlo replications of just a giant amount of simulations. So we could simulate one game about every 150 milliseconds, and that's not very optimized. So I think with the GPU, we could do a lot better. But this allows us to do update everything in real time and really get the predictions back as fast as we need. We also tested the accuracy of our model in predicting who's going to win the game, and we got about a 70% accuracy on that, which is pretty reasonable for a first pass. And you can see on the right there the calibration of our win probability as well looks pretty good.
Morning. The data we used for our shot recommender system were shots taken by NBA players throughout the bulk of the 2015-2016 season. At the heart of what we're doing basically is building a predictive model where we're trying to take into account player factors and shot factors. And one of the challenges in this situation is you've got interactions and sparsity, and that's why we ended up going with the factorization approach. You have interactions because different players are better at some shot types than they are at others. You also have sparsity because here Chris Paul didn't attempt any putback dunk shots, and Russell Westbrook is actually quite good at them. So we're looking at building recommendation systems. So you can imagine that there's a player with without a lot of experience, with a short history, taking that player aside and making recommendations for them based on their shot style. The other thing that we like about factorization machines is that to estimate these interaction terms, we're deriving latent factors. And then we can use these latent factors, which I plotted here in 2D, to find affinities between players and shots. So for example, Manu Ginobili and driving floating layups. And also you can see clusters of players with similar shot profiles. Thank you.
Hi, my name is Scott Brave. I'm from the Chicago Fed. This is joint work with one of my colleagues at the Chicago Fed, Kevin Roberts. So what we've done here is we've actually built a little game theoretic model of team behavior to try to answer a simple question. How well has Major League Baseball done in designing their PED testing system since 2005? And so what we've built here is a very simple model. In fact, I'm hesitant to even call this big data. It's big only in the macro sense in that we're modeling the league as a whole. But what we show is we can tease out some of the competitive effects that testing has had on teams over the last decade or so, teasing it through their financials estimated from Forbes, through their revenues, through their costs, through their profits and their franchise values. And the interesting thing that comes out of this analysis is we actually find that Major League Baseball has done pretty well at various times, but not so well recently. And so this quote here is from a recent quote from a Major League Baseball player, and I think the conventional wisdom is that the way to make this system better is to increase the length of suspensions that a player is subject to when he tests positive. Our analysis actually shows that might be incomplete, that you might also want to tax the team as well, a team that hires a suspended player. You can go ahead and click through to the end. Yeah. one more. There you go. A team that hires a suspended player also might need to be punished as well. And the reason for this is very simple. The suspended player, you don't have to pay his salary while he's suspended. And that actually adds a pretty big incentive for a team to want to go out and maybe hire someone that they otherwise wouldn't have. Economics 101, right?
Hi, my name is Pedro from Computer Science Department at UFMG. And we just saw that one thing about soccer is that it's very hard to characterize players using solely boxscore statistics. So players with similar statistics may be very different. And one way to understand this difference is to actually get more information. You can get more information from tracking-based data, event-based data, and our approach is to use video game data to do that, particularly from the FIFA Soccer series. So in FIFA Soccer, players have many attributes, which are much more meaningful than box score statistics. Attributes such as aggression, speed, shot power, and of course, is of the best interest of these companies to make these attributes as accurate as possible. And from historical data, from 10 years of data, we were able to perform some preliminary but interesting analysis. We could identify Barcelona as a unique team in its tiki-taka era, and also the rise of Germany squad and the fall of Brazilian squad in the past 10 years. Okay.
All right, let's thank the Spotlight presenters.